No? Yeah. You got disease problems?
Everything.
Okay. Okay. Yeah. You know, sure. You know, no problem. So what I want to talk about, I've got a bunch of slides here, but I'm going to kind of go through some of these very fast. Some of these I'm going to kind of linger on and really try to get you to think about aspects about fish health and diseases, and trying to put all of this in context about your production cycle. Because again, what we're trying to do is we're trying to help you improve your survivability at the end. So you've got more animals to be able to sell at harvest. Okay? You've got more animals to sell at harvest, then you've got hopefully more profitability. So what are the goals of a hatchery or a production system to begin with? One, we want to maximize the growth capabilities of the individual fish that are in that system. Meaning, we want that fish growing as fast as possible. What does it genetically have the capability of doing? Okay? These fish have just an incredible ability to grow whenever we're giving them everything that they need. And they can grow off very fast. Tilapia, catfish, yeah, they've got different growth rates, but when we maximize the individual there, I mean, their growth rates are just phenomenal. And what they can convert as far as feed conversion ratios, as far as the amount of feed, to the biomass, the mass that they're putting on is incredible. But we need to maximize what they're genetically capable of doing. The second goal of any production hatchery system is to maximize the production capabilities of that system in an efficient manner. In an efficient manner, that's the key. In an efficient manner. Okay? It's not just to see how many kilos that we can pull out per cubic meter of water. We have to do it efficiently. Because this is not just a production unit. This is a business. As with any business, you have ways to maximize your efficiency. So we have to do it in an efficient way. The only way that we're going to do this, the second goal right here, in an efficient way, is to do this. The only way to do number two is to do number one. Okay? So what does all this boil down to? It's exactly what Sofolabi just presented. It's your carrying capacity. If you're keeping things under your carrying capacity, just like the example he showed with those growth rates, from month 1 to month 2, month 3, month 4, month 5, you were consistently increasing the biomass that those fish were able to grow until you reached that plateau at about month 6, where the amount of mass that you were actually able to produce started slowing down. That's where you started losing your efficiency. So you have to keep in mind your carrying capacity. Now, again, whenever you start taking your animals and you're starting to put them in close confined situations, you're going to have problems. So when it revolves around fish health management and disease issues, we've got 3 main objectives. 1, we want to try to prevent disease outbreaks from ever occurring in the first place. We don't want any. So what can we do preventive-wise to stop that? Number 2, again, whenever we start taking animals, we're putting them in very close confinements. They're going to start getting stressed. We've got a bunch of pathogens that are out there. We're bound to start getting new disease occurrences. So we want to try to reduce the number of those disease occurrences. And then number 3, this is where most people just turn to automatically. But actually, this is probably the last thing that we really need to be thinking of in our order. When we do have these outbreaks and occurrences, we want to try to reduce the severity. How do we decrease the number of fish that are going to die? This would be things like treatments. Okay? But what can we do to stop all that ahead? Okay? How can we do preventive techniques? How can we reduce the number of those new occurrences? All of those things have to be kept in mind. Remember, we're dealing with a population. We're dealing with thousands and thousands of animals in one culture unit. So we can't do individualized medicine like what we do in humans. We can't do individualized medicine like what we do in other livestock industries. We have to deal with this on a population. So we have to take all that into consideration. Fish health management is also, it's a very continuous effort, and it's always changing. It's always changing. It changes with the different phases of the production process. How you manage your brood fish is very different than how you manage a larval fish that's this big. How you manage a larval fish this big is different than how you grow or how you manage for disease issues and health issues for a fish that's, say, 100, 200 grams in size. That's going to be very different than your brood fish. So how you come about it and during all those different phases of the production process, how you change all that and the way you have to approach it is very different. How you change your management practices from a small 1 cubic meter tank versus a pond is very different. And all of these aspects you have to know about. It also goes with the way of the experience and of the producer or the grower. Just like I was giving you an example a while ago, and the question come up about new producers. How are they going to approach fish health management versus one that's been in the business for 20 years? A person that's been in business for 20 years, they've seen a lot of different things. The way that they come to expect, anticipate problems developing, and how they control for it is very different than somebody that's only been in business for a year or two. So the ability to be able to recognize changing conditions and the experience that goes along with it, of being able to say, oh, wait a minute, I've seen this happen before. This has led to this, this, and this. I better stop doing whatever this is and correct the management right there. Otherwise, this is going to happen. A new producer may not be able to recognize those little subtle changes like that could lead to disastrous results. And then finally, the changes in conditions. Conditions can change from minute to minute, hour to hour, day to day, month to month, season to season, year to year. And if you don't recognize a lot of those changes that can happen, you can go from everything being perfect. Fish are growing well, but in 10 minutes, they're completely dead. The same way with conditions that change from the early morning time periods to the late afternoons. If you have a pond, you have very, very different water quality conditions. You've got differences in temperature, you've got differences in pH, you've got differences in oxygen levels. How does that affect the animal? Knowing all those little subtle differences that happen are going to occur. What happens between right now? Let me ask you this. What is happening right now in this geographical location that is so different than 3 months from now or 6 months from now? What season is this? Rainy season. How does that impact your fish? What?
They are doing well. You said they are doing well.
They're doing well, okay? But it could be that all that rainwater coming in is changing the water chemistry very much, especially if you've got a water flow coming in. And then compared to the dry season, whenever the temperatures are much higher, and you just so happen to get an afternoon thunder shower or an afternoon rain event, how could that change that culture condition? You know, it could happen just like that. Completely change everything that happens in your measurement. So understanding and anticipating the changing conditions that are constantly going on is so imperative for fish health, disease, and management around those conditions. We look at this and we take on a very multidisciplinary approach. We take a holistic view of fish health management and disease management. Okay? It's not just one section. It is a combination of a lot of different discipline areas. It includes nutrition, making sure that they've got the right vitamin and mineral mix, that they got enough protein, enough fat, the physiological condition of the fish. Sofolabi was talking about the total alkalinity. He'd come up to a pond. They just did not seem to function. You know, that pond seemed to be a very low producer. When he tested the water quality, the alkalinity was virtually zero. And we'll talk about genetics of the fish, the water quality, the disease specialist. You know, even within the areas of diseases, like the area that I'm in, I'm more of an epidemiologist, linkage to production. There's other people that are out there that understand bacteria, that understand the viruses, that understand the parasites. And if I don't know something, even though I'm a diseased person, if I don't understand something, I've got to have somebody to go to help me understand what's going on. Husbandry experts, people that understand the systems, people that understand cage culture, people that understand pond culture, recirculating specialists. So all of these people are very important as far as the team that work together to be able to help solve some of these problems. And so this is related back to you in that you need to be putting together a team. You need to have people that you can contact about these various things and about the various things that are happening up here in order to be able to understand your systems a lot better, to understand your fish a lot better, to understand the diseases that are happening out there a lot better. So that's where the importance of this really comes in. It's not just, again, throwing fish out into a pond. You've got to be a student. If you're wanting to be a good business person is always learning. They never stop learning. They're always trying to figure out what's next. How can I be better? How can I be better? And if you're not constantly being a student, especially of all this, then you're not going to solve your problems. So you get those mentors around you. You get those good financial experts around you. You get those good husbandry experts around you. A nutritionist from the feed plant that you're working with. All of those things are extremely important. Okay. Any questions up to this point? Comments? Again, I want this to be a dialogue. If you've got a comment, a question. All right, so what exactly is a disease? So this is our definition of disease. It's an abnormal physiological state or pathological condition. The key word there is abnormal. It's abnormal. If we don't know what the normal is, how do we know what abnormal is? Again, it's part of being a student. So it's an abnormal physiological state. And there's basically two very broad groups. Whenever most people think about diseases, they think about this first one, the infectious diseases, the viruses, the bacteria, the protozoans, the fungi, those living organisms that cause these pathological conditions up here. But the second group probably is more important than the first. The non-infectious diseases, like dissolved oxygen, pesticides, heavy metals. Why would I say that? Why would I say this might be more important than the infectious diseases? Why would I say that?
Because the second one can give rise to the first one.
Exactly. You're exactly right. I forgot to put this actually, like in humans, malnourished people are a whole lot more susceptible to these animals up for the viruses, the bacteria, and the parasites that are already out there in your water. They're already there. Worldwide. You have the same exact problems, bacteria, protozoan-wise, that I have in the United States with the farmers that I work with there. Same way, same exact problems that we have in Southeast Asia. Now, some of them are very different, granted, but it all boils back down to this being a predisposing factor to this. Okay? So non-infectious diseases, nutritional, water quality, different types of intoxication, whether it may be natural, it may be man-made produced. It could be genetic, or it could be types of pesticides that lead to cancerous type growths within the organism. This is an example of a nutritional issue. Lack of vitamin C in the feed, causing vitamin C deficiency. You see it here, commonly called crackhead. In this particular case here, this is caused scoliosis, where there's breaks in the vertebra, here, 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 and even up here. In this particular case, right here at this break, the bone actually punctured through the skin and caused a bacterial infection. What was the cause of the issue? It wasn't the bacteria. It was the nutritional issue that led to the problem. Water quality diseases, dissolved oxygen. This here is about a 5 hectoliter, 20,000 kilos of fish, one pond, one afternoon. Happened just like that. It was his entire profit. I'll get more into that a little bit later. The infectious disease, again, the parasites, bacteria, fungi, viruses. These are living organisms. If you notice the non-infectious diseases, I'm referring to non-living aspects, non-living entities. These are living organisms that are leading to disease changes. For example, here, in this fish here, this is caused by the bacteria Aeromonas hydrophila. You see it here. Y'all have it. Very common. That's right. Very common. That's because This organism is found in every freshwater system around the world. Fish or tropical fish. Whether it's in North America, Africa, Europe, Asia. Every freshwater system has this. Yep. So we're dealing with the same problems. So why do we need to know about diseases of farmed fish? Well, bottom line, it's money. If we can't keep our fish alive, we don't have anything to sell. If we don't have anything to sell, we better go find a different line of work. If I can't help you make money, then I'm out of a job. So the bottom line is it helps everyone. Not to mention just to be able to put food on people's plate in order to eat. But when we break it really down, not only is it money, but it's production efficiency, it's survival, it's feed conversion issues. These are all efficiency aspects. And it all goes back to carrying capacity. So one of the most common questions that I get, and I work in diagnostic labs, probably, well, almost 30 years. I've worked in a diagnostic lab in some capacity or another. The most common question we get is, are the fish safe to eat when they get sick? The simple answer, some pathogens can be human pathogens. There can be a transfer. Most of the time, though, especially when it's referring to being safe to eat, as long as the animal is being cooked thoroughly, there's usually not much of an issue. However, it's still not good practice to be able to put sick fish out on to the marketplace. Okay? It's just not good practice. Hopefully we'll get around to, I'll give you some prime examples about this here in just a minute or a little bit later on. But in a lot of cases, especially if we get a pond of sick fish and we try to sell those animals, the shelf life of those sick animals will spoil a lot rapidly the healthier fish within that population that we're sending to market. So if you start mixing them up, the shelf life usually is not very long, or it's significantly shortened. So we really try to discourage putting sick fish out on the market. We wait until either they get better, or hopefully, if we do, we try to catch it real early in the event, and then try to get them out to market very quickly. But even then, we really need to know what's causing that issue to begin with. Because, again, some of them, just through the processing, the active processing of, say, gutting an animal, if the processor has some open wounds on their hand, and they're working these fish and they get infected, they could die. Some of these are human pathogens. So we have to be very careful. We have a responsibility as producers of putting out a good product to the processors. They have a responsibility to the consumers. All right? It's a chain. Ultimately, we report back to the consumers, and we want to make sure that we get them a good product. Comments, questions? We on same page? Okay. So, I have what I call 3 must-knows about fish health management. 3 must-knows. You got to know your fish. You've got to know what the normal, healthy appearance and behavior is like. Remember what I said about disease. What is the definition of disease? It's abnormal. If you don't know what the normal is, how do you know what abnormal is? So, healthy appearance and behavior. This is also part of being that experience of a producer in understanding your fish. If you don't understand some of your animals, then we may be having a significant effect. They don't feel like eating. Is there an issue here? Same way with as a producer. If I come out onto a pond bank, and I'm expecting to feed my fish, and for the last week, 2 weeks, and nobody's there, you can kind of still see them out there, but nobody's wanting to eat. That ought to be a red flag that says, you might have a problem. I have a significant problem. What am I going to do now? What am I going to do now? So, it's probably really key. And as far as you managers out there, the personnel that you have on your farm, and especially the feeders, they are really probably one of your most important tools that you have for recognizing this. If your feed person is not observant and not really good and not reporting these kind of observations back to you, you probably need to fire them. They are your most important piece of information of what's happening on your farm. The nutrition. You got to know what the nutritional requirements are like. Is a tilapia a catfish? It's a serious question. Is it tilapia a catfish? Is it the same fish? No. No, it's a very different fish. Therefore, its nutritional requirements are very different. So make sure you know the fish and what their nutritional requirements are like, and make sure that we're providing a complete diet, a quality diet. Not just that the components are there, but that the components, the vitamins and the minerals and all that is not only can be absorbed by the animal, being bioavailable, that they can actually pull it in. What is the lateral swimming space like? What is the stocking requirements for this species of fish? That we do. Your cat that I stock my cat culture unit, you're going to start getting stunted growth and the potential for high disease transmission. But if you've got too low of a density, these animals, they're very, very keen and very aware of one another. And they start establishing a socio structure, dominance, subdominance within that. They will start fighting. Really, bacterial infections. Because if they start gnawing on one another, biting their sides and scraping it up, it's bad. What are the water quality requirements like and the tolerances? Oxygen, ammonia, nitrites, pH, temperatures. I can't grow tilapia in the U.S. year-round. If I leave them outdoors, there's only just a couple areas in the U.S. that you might be able to do this year-round outdoors. Just a couple. But pretty much, our producers cannot grow tilapia year-round. Very different than here. Okay? That's because whenever the temperatures in the U.S., they start getting down around 15 degrees, the water temperature gets down around 15, the animals start dying. That particular species does not have the capability much lower than that. So, understanding your animal and the requirements for all of these things are part of understanding the fish. That includes knowing what the outer extremities in the anatomy is. And this is a conglomeration of different fish. Okay, this is not a particular fish species. Actually, it's just a figment. But understanding each of these various anatomical parts is important. Not only on the outside, but open it up and learn what the inside looks like. So again, know your fish. If you are not meeting all those biological needs of the fish, if you're not meeting any of those, you start inducing stress and the stress response. These are physiological changes that occur by the animal in response to physical, chemical, or biological factors that animal perceives as being harmful. Whether it's harmful to them or not, it doesn't matter. They're perceiving it as being harmful. And as we all know, sometimes perception is actually truth to that particular person. So how they respond to these different situations is the first key in understanding disease management and health management. If we don't know what the normal requirements are for the animal, we start getting into this right here. When we start getting into stress, there's a number of factors that start happening. Just like in humans, whenever we start getting stressed out, whenever my wife comes to me wanting more money and complaining to me that I don't make enough money to support her shopping needs. My kids come home from school with bad grades. One of them wants to go out on a date with a boy I don't like. Shut up, Flavia. And then, my parents are sick. What does that do to me? That causes me to get stressed. When I get stressed, I get sick. Okay? Same thing that happens with these animals. If we don't meet all their biological needs, and they're not just in a state of bliss, they're stressed. And all of these events start happening. And all of these are negative things that happen. These are the predisposing factors that we were talking about. We get all kinds of different changes in our hormones. We get increased ventilation rates of the gills. They're going to start breathing heavier. Because my daughter comes home and she starts telling me some of the things she does. I'm like, part of that response is a lot of mucus production, especially on the gills. If you start getting a lot of mucus production on the gills, that stops water from flowing across those gills properly. If that happens, they can't get enough oxygen in. That makes them even more stressed. That makes them try to breathe and expend more energy. Instead of that energy being diverted to growth, they're just trying to now stay alive. You get a redistribution of the blood. Generally, what will happen is, instead of it going towards the skin as a protective mechanism, to the intestines to help absorb nutrients that are vital for growth, and to the skeletal muscle tissue, what's important about that? That's the part that we sell. That's what the consumers want. They want the flesh. We start getting blood diverted away from these areas, and they're putting it to the vital organs just to survive. Anytime we get this, that can lead to oxygen-deprived tissues. Whenever we get deprived tissues, we can get localized tissue death. So, if we're bringing blood away from this muscle tissue, the muscle tissue starts to die, then all of a sudden, we've got an issue with our product. we've got an issue with the quality of our product that we're selling to the consumers. Much less, probably the final thing that impacts is suppression of the immune system. If we don't have a really good functioning immune system, all these pathogens that are out there in the water, they start affecting the animal. They can then overwhelm and overtake the animal and kill it. This is what we're trying to prevent. Okay, before I move on, any questions or comments? So it's crystal clear. Yeah, say it.
Yeah, interestingly, there's something that stuck with, which most times I've never taken cognizance of, and it's about understocking too. That it has a negative effect, and that means if there are not so many in the pond, they start attacking themselves. They know themselves, so they start having dominance or territorial behavior. So it stuck me. It never occurred to me ever since. So I said that's a good one. So
Yeah, yeah, that can happen, and that's probably more important from a breeding standpoint more than traditional, production size. But that's why we come up with the particular ratios of males to females within the breeding systems because of the different pheromones that they're producing. You start getting dominant, subdominant animals, they're getting territorial. All of that can be impacted. It's probably from a production standpoint, especially on smaller fish, it's real important, like in tank culture. That's where I see most of the problem is when you got just a few animals in a tank. And not so much in a pond, but in a tank. They can get real territorial real quick for the sub-adults like that. But yeah, it can eventually affect it, because even if you've got a mixed size of animals in a pond, why we really recommend you have graded individuals throughout the process is what happens to if you've got a pond that are full of fish this size, but yet you got a few that are just, like this. They kind of get shoved out to the side, and they don't grow quite as well because they kind of get just bullied out from the feeding area. So they can get extremely territorial, and it is definitely something to consider long term.
then also in addition to, if you want to optimize production, because result is very important, and the stocking rates or the stocking density too varies per location or per management too. So, and if you're considering optimization, so what best can inform you that, okay, this is the best recommended stocking density for me as regards the kind of system I run or my operational.
Yeah, that's where it goes back to a lot of the stuff that Sofolabi presented about that graph and doing periodic sampling process to understand exactly where you're at on the average size and the growth rate, the intermittent growth rate that you're getting, and making sure that you're keeping track of that every production cycle, and then using that information to go back and check your records and see, is this pond on par with where I should be? And so for a new producer, it's very important to start this immediately and doing these sorts of things correct. But looking back at that graph is where it's really important to understand where you're at in that process.
Now, for what I'm asking is, as a consultant, I want to know if specifically now, so you won't misinform your clients. That, is there a rule of thumb that, okay, if I go to Sofolabi's farm, a lot of people do copy and paste when it comes to farming practices in Nigeria. So if I go to Sofolabi's farm now and I see Sofolabi is talking 100 fish per square meter now. And I just said like, okay, okay, let me see Folabi's pond. Folabi's pond is about 10 by 20 meters, and it's got about 5,000 in it. I won't bother understanding the stocking management of Folabi, the practices on this farm. And looking at the surface, you won't even know the depth. Few clients that have seen maybe on during the excursion have seen what Folabi has in his farm.
Yeah.
He calls, said, let me use the normal Nigerian language. Said, I don't dig pond. He has gone ahead to prepare the pond without informing a consultant. And he now tells me, okay, what should I stock? And I tell him, okay, you know what, stock 20 per square meter or 50 per square meter. He will now be like, what is he telling me? You want me to waste my money? When Folabi is talking about 5,000, the same capacity. So what I'm now trying to drive at is that looking at all of the conditions, is there a rule of thumb that can tell you specifically that this is what you stock